Students always ask, what are conic sections? When am I ever going to see this in the real world? What are the differences between them? Let's start finding some answers. The term conic sections leads to a term most students understand, the word cone, most commonly seen as in an ice cream cone. Now surely every student has seen an ice cream cone. To apply this to math, we're going to look at two ice cream cones, one on top of the other from tip to tip. No ice cream here though, we're just focusing on the cones. With the two ice cream cones touching from tip to tip, we see what is beginning to form where we get our math terms for the types of conic sections. They come from two cones. Here's the view of the four types of conic sections. As you can see here, there are circles, ellipses, parabolas, and hyperbolas. Each represent a cross-section of the two cones, thus the math term conic sections. So now that you know what conic sections are, you might ask yourself, when am I ever going to see this outside of math class? So glad you asked. Let's start with the easiest one, circles. Circles are the cross-section of the cone by a perfect flat plane slicing out a circle. Circles are everywhere. Here's a wheel of a car. How many circles do you see in this picture? 2, 5, 6. Keep looking, there's at least 9. How about sports? Think about all the circles you see. Circles around a basketball is one, but how many can you think of in a basketball game besides the ball? The rim? The jump circle? Where else? Circles are everywhere in food too. How many can you find in this pepperoni pizza? What other foods? Hamburgers? Buns? Tomatoes? Pickles? Cucumbers? Cheerios? They're everywhere. Okay, circles are easy to see. You take a slice of a cone and you get a circle. But what happens if that slice becomes at an angle? Then you get what we call an ellipse, a stretched out version of a circle. Let's look at some examples of ellipses. Ellipses can be seen every day in mirrors, such as this one. You might also see mirrors that are ellipses in your cars or on motorcycles. Ellipses show up all the time in architecture, like this building here. While we may not see these every day, the orbits of the planets in the solar system are all on elliptical paths as well. Okay, we got its circles and ellipses down. Now, what about parabolas? Parabolas occur when we slice one of our cones at an angle for the cross-section. The resulting U-shaped line is a parabola. Here's the use of parabolas in modern-day science. Have a feeling everyone's seen these two parabolas. Some people refer to them as the golden arches, but really, they're parabolas right in front of your eyes. Parabolas are used all the time in designing things, especially things like roller coasters. Parabolas occur naturally in the flight of objects. Think about water shooting out of a fountain, or a dolphin jumping out of the ocean, or even the flight of a basketball, baseball, or football in sports. Okay, 3 down, 1 to go. Last one is hyperbolas. You think you can remember one more? Hyperbolas occur when both the top cone and the bottom cone get sliced a cross-section by one single plane. This results in two U-shaped lines that are mirror images of each other. Hyperbolas are harder to see in the real world, but they are there. Can you see the hyperbola in this hourglass? Hyperbola is used a lot in architecture design as well. Can you see the hyperbolas on each side of this building? Hyperbolas also occur naturally. Look hard at this picture of the light given off from this lamp. Can you see the curve of the light up high on the wall and down low on the wall that is the mirror image? That is also a hyperbola. Whew, got them all. Circles, ellipses, parabolas, and hyperbolas. 4 types of conic sections. But what do they have to do with math? Well, like most objects, they all have equations that apply to them. Here's the equation of a circle. Notice how the x and y are both squared and it equals the radius squared. Now we see the equation of an ellipse. Notice how similar the equation of the ellipse is to the equation of the circle was. Just as the two shapes, circles and ellipses, are similar. The difference is ellipses are always equal to 1, and we always divide them by a squared and b squared to show how stretched out the circle was to become the ellipse. Here's the equation of a parabola. The last equation is that of a hyperbola. Again, notice how similar it is to the equation of an ellipse. Ellipses have a plus sign in between the x and y squared, and hyperbolas have a minus sign in between. Think of it as a plus sign brings two curves together, forms an ellipse, while the minus sign keeps the two curves apart, forms a hyperbola. So let's review. Here again is our 4 types of conic sections as a picture. And here are our 4 types of conic sections as math equations. Again, see the differences between circles and ellipses, and between ellipses and hyperbolas. Got it? Great. Now pat yourself on the back. You are a member of the conic section family, and as a member, your assignment is to draw a picture using all 4 types of conic sections. Ready? Go.